What if I told you our solar system map, the one you learned in school, might be wrong? Like fundamentally incomplete? For years, astronomers have whispered about it. A ghost, a massive hidden world lurking way out there, beyond Neptune. A ninth planet. Sounds like sci-fi, right? Well, those whispers just became a shout. Forget shiny new telescopes for a second. The biggest clue might have been hiding in plain sight, buried in data decades old. Are we on the verge of rewriting everything we thought we knew about our cosmic backyard? Let's find out. So Planet 9. The idea isn't new. We've seen weird things happening at the edge of our solar system. Icy bodies moving in ways that just don't make sense unless something huge, something unseen, is pulling their strings. Think of it like cosmic puppetry. We see the puppets dance, but we haven't seen the puppeteer until maybe, just maybe now. This isn't just another theory cooked up from calculations. This time it's different. Researchers did something incredibly clever. They took old sky maps, infrared maps, captured by two different space missions, one from way back in 1983, the other from 2006 and 7. That's a 23-year gap. Why dig up old files? They decided to make a time-lapse, a cosmic time-lapse. See, if Planet 9 exists hundreds of times farther from the sun than Earth, it moves across our sky agonizingly slowly. A crawl. Barely a flicker over months, even years. But over 23 years, you might just catch it shifting position. So they compared the maps. Imagine overlaying two incredibly detailed photos of the night sky, taken decades apart, looking for one specific faint dot that moved. It's like finding a single shifting grain of sand on an enormous beach. They had to filter out everything else. Distant galaxies, glowing dust clouds, all the background noise of the universe. They used some smart tricks, focusing on things that appeared, then disappeared, then reappeared somewhere else nearby in the later images. A moving target filter, basically. They knew roughly what they were looking for. Something maybe 7 to 17 times the mass of Earth, chilling out 500 to 700 times farther from the sun than we are. A super-Earth or a mini-Neptune, incredibly cold but still glowing faintly with its own leftover heat from birth. That heat signature, that infrared glow, is the key. After sifting through countless possibilities, weeding out false alarms hidden in cosmic dust clouds, they were left with one. One prime suspect, a pair of detections, one from 1983, one from 2006. Here's the kicker. The spot seen in 83, empty in 2006. The spot seen in 2006, empty back in 83. It wasn't two different things. It looked like one thing that had moved, and the amount it moved, about 47 and a half arc minutes over 23 years. How fast is that? It works out to just over 2 arc minutes per year. And guess what? That fits perfectly within the predicted speed for Planet 9 at that immense distance. It's right in the sweet spot. Plus, the later observations showed the object appearing and disappearing over months, consistent with something moving slowly near the edge of detection, not just a fixed background smudge. And crucially, no dusty clouds nearby to confuse things. So, wow, this isn't just finding a new rock. If confirmed, this is monumental. It would be the first planet found by prediction since Neptune, almost 2 centuries ago. It would finally explain why those distant icy bodies, the Kuiper Belt objects, are huddled together in weird clusters, like they're being herded by an invisible giant. It validates the whole idea that our understanding of the outer solar system is incomplete. Think about it. A massive world, 5, 10, maybe 15 times Earth's mass. Likely an ice giant, a smaller cousin to Uranus or Neptune, with a thick atmosphere, incredibly cold, maybe minus 220 Celsius, radiating its own ancient heat into the void. A world taking maybe 10,000 or even 15,000 years just to go around the sun once. But hang on, this is still a candidate, an incredibly compelling one, but we need proof. What now? We need confirmation. We have 2 points in time. We need a third. Telescopes like the powerful dark energy camera in Chile are likely pointing right now at the patch of sky where this object should be today. based on its predicted movement. They'll take pictures night after night, looking for that tiny telltale shift against the background stars. If they find it, if they get that third data point, that's the game changer. That lets us start plotting an orbit, confirming it's really part of our solar system. This whole story, it's like a cosmic cold case cracked open by detectives using decades-old clues combined with modern know-how. It's not just about bigger telescopes, it's about asking smarter questions of the data we already have. Forget Planet X doom theories or mythical invaders. This is real science pushing the boundaries. It reminds us that even in our own solar system, vast secrets might still be hiding in the dark. We thought we had the neighborhood mapped out, but maybe, just maybe, there's one more giant out there, waiting to be formally introduced. The hunt is on, and the next chapter in the story of our solar system could be written any day now. What else is hiding out there?